Back on track. So, for those of you who missed what I said earlier, I just basically said that Daphne completed her PhD at the University of Minnesota, after which she moved to McMaster University, and where she took up a faculty position. Her research is focused primarily on the development of visual perception in the very young, and she's also worked in the field of synesthesia. So to say that Daphne has been prolific is an understatement. If you look online at any number of sites, they'll say that she has published over 200 research articles. And I didn't count them all, but I think it's probably closer to 300. Daphne can correct me if that's, nope, she shakes her head. There's more than 200 for sure. These include numerous articles in the premier scientific journals Science and Nature. And according to Google Scholar, her work has been cited over 22,000 times. That's a big number. Very strong, as somebody south of the border would say. In addition to her primary research article, Daphne and her husband Charles have co-authored 2 books and currently have another book in press. Their first book, The World of the Newborn, examined the development of the newborn baby from the baby's perspective. A reviewer in the Journal of Pediatric Psychology called it a landmark book that offered a startlingly fresh perspective on their subject matter. This book won the Book Award of the American Psychological Association. Her research is indeed impressive, but here's the thing. Daphne's work has not been confined to the hallowed halls of academia, but she's made significant practical contributions. In 2020, Daphne and her co-authors reported on the feasibility of screening children in kindergarten for undiagnosed visual issues. This report led to the province of Ontario implementing, under Daphne's guidance, and I can remember at the time she was buzzing off all over Ontario seeing this be implemented, a province-wide school-based program to screen kids in kindergarten to ensure the early detection of problems with vision. The success of this program is attested to by the fact that it is now being taken up by other jurisdictions. And a couple of years ago, Daphne spoke to us about this program. More recently, Daphne was a member of a committee of the National Academy of Sciences, Engineering, and Medicine in the States to study the increasing problem of myopia in children. And this will be the subject of her talk today. Daphne's work, not surprisingly, has received widespread recognition, and she has been the recipient of numerous awards. And I'll just name a few. She won the Donald O. Hebb Distinguished Contribution Award from the Canadian Society of Brain, Behavior, and Cognitive Sciences. She was named a Distinguished University Professor by McMaster. She became a Fellow of the Royal Society of Canada in 2007. And in 2024, she was nominated an Officer of the Order of Canada. So just finish by reading to you the citation, if you look online, that the Order of Canada has for her. And I quote here, "Experimental psychologist Daphne Maurer has reshaped our understanding of the sensory world of infants. She is internationally renowned for her research on visual and cognitive development during early childhood, which led to new clinical practices and improved patient outcomes. She was also instrumental in developing and implementing Ontario's Universal Vision Screening Program for kindergarten children, an initiative that is spreading across Canada." So that really says it all. So Daphne, I'll hand it over to you.
Thank you so much, Jim, for that, introducing that stellar person I don't really recognize. I'm here to talk about something that's invisible and increasing at pandemic levels. And here, it was supposed to be a graph. Okay, advance the first slide by, oh no, come on, we're not going to have problems. There it goes. Okay. Here is the prevalence of this problem in China. There's a study in China of over 5 million children. So these are pretty good data showing from the year 2000 to the year 2020, the prevalence of this problem. And you can see for the rural population, these are children in grades 10 to 12, it's increasing. It's already pretty high in the year 2000, and it's going up. And if you look at children who are in grades 4 to 6, it's increasing really rapidly. Whatever this is, what is it? Well, Jim in my abstract give away the punchline. It's myopia or nearsightedness. Now, what happens in nearsightedness is that the eyeball is too long. So in this example, light is coming in from the world and it's being focused. Where's my pointer? Well, I guess I don't have a pointer. Okay, it's being focused in the middle of the eyeball, which means that it then spreads out and is a blur on the retina. And that means this child can only focus on things that are very near to the face. To fix it, you put a concave lens in front of the eye to decrease the amount of focusing. So now the light is focused right on the retina. And the worse the problem, the worse the eyeball is too long, the stronger lens there is that you need to fix it. So just to give you an idea of what it's like to be nearsighted, many of you are now nearsighted, so you know what it's like, but let's go through these slides. So if you're at the doctor's office, you're looking at the eye chart at 6 meters away. And if you are not nearsighted, it's imperfectly focused and you don't need any extra lens. If instead you can only focus out to 1 meter, it'll be a bit blurred, and you need a 1 diopter lens to fix it. So we measure the amount of myopia or the strength of the lens in diopters. And it's actually the inverse of where you're focusing. So if you can only focus out to 0.5 meter and everything beyond that is out of focus, you need a 2 diopter lens to fix it. And if you can only focus out to 1/3 of a meter, everything beyond that eye chart is very blurry now. You need a 3 diopter lens to fix it. So the worse the problem, the stronger the lens you need. And that means your eyeball is getting longer and longer, which puts you at risk. You are stretching the retina if you have a very large amount of nearsightedness, of myopia. You are stretching the retina so much, you're at greatly increased risk of retinal tears, retinal detachment, macular degeneration, glaucoma. This is more than just a pair of glasses. This is stretching the retina and putting it at risk. So imagine what it's like to have really high myopia. And it's usually defined as anything more than 6 diopters. That means you can focus out to 1/6 of a meter, and it gets blurrier and blurrier as it gets farther out. And some people are even 10 diopters myopic. They can focus to 1/10 of about their nose, and then everything else is out of focus. So this is the prevalence in that same study. These are the urban data of how many children have high myopia and how it is increasing over the same period. So we have an increase in nearsightedness, and we have an increase in the amount of nearsightedness, high myopia, that is really worrisome because it's affecting and stretching the retina. Those bars, those are the 95 confidence intervals, essentially all the dots, all the measurements are between them. Okay, so why am I here? Jim just told you I study visual development and did a little work on vision screening. I'm not an optometrist. I'm not an epidemiologist. Why am I here talking about this invisible pandemic? And the reason is perhaps because I studied development and did some work on vision screening, I ended up on this expert panel of the U.S. National Academies of Science, Medicine, and Engineering to do a consensus report of the state of knowledge of this increasingly common disease. And you'll note we called it a disease, and we called it a disease because the retina is being stretched, and also because it shouldn't be happening. We have evolved mechanisms that I'll show you work from fish to rhesus monkey to control the growth of the eyeball. So this isn't supposed to happen. So something has gone wrong in our current environment that's allowing this pandemic to emerge. I have a copy of our report here. It's very, very thick. And it was fascinating to be on this expert panel. I learned a great deal and became rather passionate about this topic, which is why I'm here today. So I showed you data from China. What about the rest of the world? What about North America? Can we produce a heat map where it's redder if myopia is worse in kids? We can't. We have no idea. Because to do that, you would need everywhere you're putting on the map that there be representative samples where the myopia was measured well, where the same cutoffs were used in different parts of the world, and where you tested the same ages and did it in the same year. It's no good if you test Nigeria in the year 2000 and France in the year 2020. That doesn't allow you to make a comparison. And we don't have those data. So I can't tell you a worldwide comparison. I can tell you a little bit about what happens within an area. So I showed you data for China, where they always had representative samples, they made good measurements, they had consistent criteria, and they repeated the same thing year after year. And such studies done all over the world show that myopia is increasing everywhere. Even in Africa, where it doubled in the first decade of the century between 2000 and 2010, and then doubled again in the next decade by 2020. For North America, I'll tell you in a minute, we have zero data on Canada, but I can show you some data from the United States. These are some of the rare good data from the United States. So in Rochester, Minnesota, year after year, they have measured the amount of myopia in a representative sample of young adults, 25 to 34-year-olds, and they've done it for more than 50 years. So there's a really good data to see in North America, is myopia increasing? And you can see that from 1968 to 2015, the prevalence just goes up steadily. And if we look at high myopia, it's also going up steadily. Now, I should note, these are good data because they've done the same thing well over and over and over again, but it's not a representative US population. Rochester, Minnesota is probably 99% white. It's not a typical population of the United States, but it's good data showing that myopia is going up. Canada, there are no data countrywide. There are no data on an individual province. There are no data on an individual city. There are no data on a county or municipality. But we can assume that since it's going up, myopia is going up worldwide, it's probably going up here too. Now, to understand why this is particularly puzzling, because we're going to play detective and try to figure out why it's happening, I need to tell you about that mechanism that's been conserved from fish to rhesus monkey. This has been shown in all the species pictured there. So it suggests it's a very old evolutionary adaptation that's been well conserved. And we're going to slowly go through this graph. It shows you data for 5 species: the chick, tree shrew, rhesus monkey, marmoset, and guinea pig. But it's a very complicated slide, so we're going to go through it slowly. So let's start with the axes. On the x-axis, it says lens distortion. And what's happening in this experiment is a researcher is taking a lens and making the eye artificially myopic or artificially farsighted. And then the eye can stay that way or can compensate by growing just the amount less or just the right amount extra. So there's going to be a lens to make the eye artificially too short or too long. And then we look to see if growth compensates for that distortion. So the dotted line is at 0, 0, because if the lens is 0, it doesn't distort at all. You don't need any compensatory growth. Now, we can use a lens, that's the dark line on the x-axis, that makes the eye somewhat myopic. So I have a picture of the eyeball. It's somewhat myopic. The focus is in front of the retina. And to compensate, it needs to grow less by the amount where I've put the dot. And then everything will be fine. The eye will not be myopic anymore. Or I can use a lens, that's the dotted line now on the x-axis, that's a little weaker. Now the focus is closer to the retina and there's less compensation needed. Or I can use a lens that's a little bit stronger so that the eyeball is even shorter, your focus is even closer and you need more compensation. Or I can really go for broke, I can keep going and you need more compensation. So perfect compensation is going to be line going up at 45 degrees, which means there's some mechanism that detected that blur, knew the sign, knew the blur was coming from being too long, and adjusted to growth perfectly. So here are what the data actually look like. When the eye is made myopic by a lens, it grows less in all 5 of those species. It does so perfectly near 0, does so perfectly all the way up in the chicken. In other species, it doesn't do so well when you get to really, really strong lenses. But in all of them, there is appropriate compensation for the amount of distortion. And we can go on the other side where we've made the eyeball too short. And look, it perfectly grows more to compensate. So there's exquisite regulation of eye growth. When the input is blurred, growth compensates, and it compensates in the right direction for what's causing the blur. This is also seen in fish and mice. It's seen in infants in the first year of life. All eyes are a little bit farsighted in the first year of life. They grow not to be farsighted. And if you're a little bit more farsighted or less farsighted in the first year of life, there's appropriate compensation. So I need to tell you one other thing. This all happens during a critical period early in life. This wouldn't work for us. This mechanism is long gone in us, but during infancy and childhood, this mechanism works across species. So what's gone wrong? Why in this kind of environment we live in now is this not working? Because if it were working, we would not be seeing an increase in myopia. So there's something about our modern lifestyle that's preventing this mechanism from working. And the first thing that usually comes to mind, well, it must be screens. You know, kids are spending hours on screens, they hold them close, and that's true. There is a great study in the United States that's done every year. The last data were collected in August 2024. They have a representative sample. This was parents' estimate of the number of hours per day their child was on a smartphone for those under 2, 2 to 4, and 5 to 8. And it's over 3 hours a day for those 5 to 8. Same study. These are the number of children already owning their very own tablet. I don't mean using their parents' tablet. I mean the parents have bought one for the child. And you see by the time they get to be age 4, it's over 50%. And these are the number already owning their own cell phone. So the use is ubiquitous. Is that causing the increase in myopia? Well, I'll remind you of these data from Rochester, Minnesota. This is where we started. In 1970, when this pandemic is starting in Rochester or continuing in Rochester, young adults were not on smartphones. They hadn't even been on computers when they were young. So it can't be the cause of the beginning of this pandemic. And if you consider these data from rural China and look at the year 2000, I think children in the year 2000 in grades 4 to 6 in China probably did not have screens. So it's not the origin of the pandemic. It's possible it's exaggerating it or exacerbating it. So this is a study of over 300,000 children. So what's shown is the number of hours a day they were on a screen, according to a parent, and the odds that they will become myopic. So as a baseline at 0, we're going to take whatever that number is as a baseline, no hours per day on a screen. There's no increased risk of myopia. And as the number of hours per day increases, the risk of myopia becoming myopic increases. So it's twofold if you're on a screen for over 5 hours. So maybe screens are making it worse, but it's not where it came from. So where might it have come from? Could this be the culprit? Maybe screens are replaying something that's been known for over 150 years. Going to school seems to make you myopic. It's long been known that people in professions like ours are much more likely to be myopic than people who are laborers. The greater hours of education, the greater hours of near work seem to lead to myopia. A classic example is among the Inuit. These are Inuit children in 1924. And then there was Western contact. The children went to school, and myopia changed from being well less than 20% to being well over 50% when the Inuit children went to school. The same thing was seen in England when the school leaving age was changed from 15 to 16. So you have a whole cohort of kids who had one more year of schooling. And guess what? Prevalence of myopia went up. And we can see this in data from Israel. In the year 2013, virtually every male, even the ultra-Orthodox, had to report to the army. Israel fluctuates politically in whether the ultra-Orthodox are exempt or not from the army. In this year, they all had to report, and there were over 20,000 of them. All of them had their vision tested. So this is the prevalence of myopia in blue on those recruits as a function of what kind of school they went to. When they went to a secular school, it's just over 25%. When they went to an Orthodox school, it's just over 50%. And if they went to an ultra-Orthodox school, it's up over 80%. Well, what happens when you go to an ultra-Orthodox school? You start at age 3, not age 6, and you read at least 3 hours more a day than the other children. So you get much earlier and much more near work. And you can see the same pattern for high myopia. Myopia more than 6 diopter, really, really short eyeballs. That's shown in green. And you see high myopia is over 25% in the ultra-Orthodox. Now, as a scientist, to really be convinced there's an effect of schooling, I want there to be random assignment. I want to be able to take children and say, okay, you're going to school and you're not going to school. But of course, we can't do that. But we have data from Shanghai that are pretty close. So these are data from almost 1 million children. They're from children age 4 to 14. And the school starting, the birthday for starting school is September 1st. So if your birthday's on September 1st, and you're 6 years old, you start school. If your birthday was in March or June and you already were 6, you start school. If your birthday is September 2nd, you wait an entire year before you can start school. So what that means is we have children who are virtually the same age. Think of August 30th birthday versus September 2nd birthday. And one of them has had an entire additional year of school. And here's what happened when they were followed up. They followed them up every year. These are typical data from when they were 9 years old. So at the bottom, you can see early birthdays, 1 more year in school, and then after the vertical line, later years. This is the degree of myopia at age 9. Each dot is from an individual child, and the blue line is the mean. So if we look first all the way over to the right, these are the kids who've had 1 year less school. There's some dots right down towards the bottom. There's some kids who have no myopia at all. And if you look over to the kids who've already had 1 more year of school, nobody's near the bottom. Everybody has myopia, and a lot of them have quite a bit of myopia. And you can see that in the mean. The blue line is much higher on the left than on the right. And this continues year after year. By the time they're 18, everybody's caught up. Everybody's had the same number of years of school, and virtually everybody in Shanghai is myopic. So schooling seems to matter. It seems to make children greatly increase the odds that a child will be myopic. Why? We don't know. There's a speculation. But the speculation is that when we're doing near work as a child or even now, we tend to underfocus a little. So we're almost perfectly focused, but we just fall a little bit short. That means there's a little bit of blur, which is misinterpreted by the mechanisms in our brain as the eyeball being a little bit too short. And then that evolutionary adaptation kicks in and the eye grows to make up for being a little bit too short. That still leaves us with a puzzle. Why was it already going up in 1990 in Rochester, Minnesota? What happened in Rochester, Minnesota? They've been going to school for years. What happened in 2000 in China? It's not the year that school was invented. And why can't we fix it? Because you would think that if the problem is a little bit of blur because you're underfocused, give the child a pair of glasses and it's they're a little nearsighted, but they should never get more nearsighted. But I'll tell you in a moment that fixing the blur with a pair of glasses doesn't stop it. The eye keeps growing. Kid keeps needing stronger and stronger glasses. So something's kicked in that doesn't seem to respond anymore to that evolutionary adaptation. So we thought when we were writing this consensus report that we'd recommend eliminating school and that would cure this disease of myopia. But before we did that, we wondered if the field has been fooled for over 100 years about the real culprit, because when you're in school, you are not outside. And maybe it's being outside as we were evolving, that's critical to something about the biological mechanism for regulating eye growth. And there are a lot of studies to suggest that. I'm going to just show you one. So in this study, which was done in the United States, they started in grade 3 with a large cohort of kids, none of whom were nearsighted, none of whom had myopia. And they collected data on the parents' vision, the time the child spent outdoors, and how much near work they did outside school. It's a lovely design because at this point, the parents who are telling you about outdoor time and near time have no reason to be biased. They have no reason to say, oh, my kid's a little nearsighted. It must be because they're reading too much, because none of these kids are nearsighted. So it's pretty unbiased data at grade 3. Now we go to grade 8. Some of the children have become myopic and some did not. And so that allows us to ask what was going on in grade 3 that predicts who's going to become myopic. And here's part of the answer. Did I say grade 8? Well, that should say grade 8. Myopic and grade 8 are not. Okay. So how many hours you were outside in grade 3, that's on the x-axis. So 0 to 5 means you hardly ever went outside during the week. More than 14 means you lived outside when you weren't in school. And this is the probability of being myopic in grade 8 or 9. And you see not very many kids are myopic, except those who never went outside in grade 3. Those are the data for children who had no genetic risk. Because we know there's a genetic risk. If you have 2 myopic parents, the chances you are going to be myopic go way up. If neither of your parents is myopic, the risk is pretty low, as you can see here. Not a lot of these kids are myopic as long as they were going outside in grade 3. If you had in grade 3 more risk because you had 2 myopic parents, look what's happened. This effect is exaggerated. So 60% of those kids who weren't going outside at grade 3 are myopic when they get to grade 9. And going outside, when you have that big genetic risk, obviously is protective so that the risk of myopia goes down. What we know from this literature, study after study, spending time outside is protective against developing myopia. Once you get it, it doesn't slow it down. So once that something kicks in and the eye starts growing too much, we don't know how to stop it, and going outside doesn't work. But being outside keeps everything regulated and keeps the myopia from starting. Okay, we can also look at these data and ask, what's the effect of near work? And what they show is, as I've shown you, having myopic parents matters, time outdoors matters, but if you control for those, there's no additional effect of near work. So we can cross it out. What matters is outside. And if you're doing a lot of near work, probably you're not spending much time outside, but it's not the real culprit. Lots of studies corroborate that. In fact, in Australia, which is a very much outdoor culture, it's one of the world's lowest rates of myopia and highest rates of skin cancer. Okay, why would outdoor time matter? We don't really know. It seems to have something to do with the light level, which is 100-fold greater outside than inside. It may have something to do with the fact that you're getting full spectrum light, so you're getting both long and short wavelengths, which seem to be important to allow the brain to figure out whether your eye is too short or too long, and therefore to compensate in the right direction might be what you do when you're inside versus outside, or maybe it's all of those. We do know there's a special class of neurons in our eye that we don't use for seeing. They detect the light level. That's all they do. They detect the light level. And when they're stimulated by very intense light, they trigger a circuit that controls chemicals like dopamine, which are part of a circuit that controls eye growth. So that may be why being outside matters. So instead of abolishing school, we should have time outside. We should have recess. And in fact, there's a study that was done in China where they took kids in grade 1, and in 6 schools, the kids spent 40 more minutes every single day outside. And in 6 schools, they just went on as normal. And they came back 3 years later. So these children are now in grade 4. So the ones on the left have had 40 more minutes outside for 3 years than those on the right. And the prevalence of myopia is 30% for the outside group and 40% for the other group. So more time outside helps prevent myopia from developing. So let's go back and look at the evidence that made us think that going to school was the culprit. or that maybe screens were the culprit, and think about time outside. So when we introduced schooling for the Inuit, they stopped spending so much time outside. When the ultra Orthodox go to school at age 3 and spend 3 more hours each day reading, they have less time outside. And when you start school 1 year earlier, well, let's talk about the kids who had slightly later birthdays. They had a whole year before school to be outside. And hours of day on the screen, well, what's the kid on the screen's not looking at the screen outside? So this may be anti-correlated or negatively correlated with being outside. So we suspect that the cause of the pandemic has something to do with kids not spending enough time outside, and that we were fooled in thinking it was schooling or screens. So what happened just before the turn of the century that caused this increase, this pandemic? I can only speculate, but I'm sure you all know that parents got very protective. They got paranoid. Children were not allowed to walk to school. They had to be driven to school. They can't play outside on their own. And the protective effect has just kept getting, I will say, worse. That shows you a prejudice over time. And the same thing was probably happening in China as well. Okay, so who cares? It's just a pair of glasses, isn't it? I've already told you that once the eye starts growing, it just keeps on growing. The kid will need new glasses every year. The eyeball will keep getting stronger, more stretched, more at risk. There's some treatments that are being tried. They're in clinical trials. It's a bit challenging because you need to leave some blur to tell the eyeball it's too long and it should do something. But you also want the child to be able to see the book and the blackboard. So it needs perfect focus and some blur. So they're very clever contact lenses where the rings of perfect focus and rings of blur. There are drops that blur vision for part of the day, and the rest of the day vision is clear. So all of these treatments are trying to give the brain some perfect focus and some blur. And they work just a little bit. They don't reduce the increase in myopia by even 1 diopter. Tiny effect, and it lasts for a year. They work over a year, and then they don't work anymore. So we don't really know how to slow this down. What's happening in Canada? Well, we can assume it's increasing here. We don't have data. And what are we doing about it? What are we doing to detect it, diagnose it, treat it? It's very easy to detect. I could hand you one of these devices, and you could take a picture of Mila at the back, and you would have the answer in 30 seconds. And in this case, it's telling you this child is myopic in both eyes, minus 250 and minus 425, I think is what it says. Problem, that machine costs $10,000, so they're not widespread. But we could take this eye chart, children can read it. If you adapt it a little bit, certainly by age 4, most of them can do it at age 3, and you ask the child to read the eye chart 1 eye at a time and see if, when it's 6 feet away, it's clear for them all the way down to 20/20. And we can do that in less than 10 minutes with a 4-year-old. And they like the games. So in one of our studies, we asked the kid after they did these games, we called them, what do you think? And most of them chose the smiley face. Actually, the frowny face was from a child who had failed so badly in the first test, she only got to play 1 of the 5 games, and she was mad about missing the other 4. Okay, and you could do the screening in shopping malls, community centers. You could, better yet, do it in schools. There's a captive population. So what are we doing? In 2021, these are all the provinces and territories that were doing no vision screening in schools at all. None in 5 provinces and 2 territories. This year, British Columbia decided to stop doing it. And what's happening in Ontario? Well, as Jim said, through the work that my colleagues and I did, we got vision screening back into the public health standard in 2018. It says every public health unit has to make sure it happens in schools during kindergarten. We have multiple public health units in Ontario. They're a bit self-regulating. So some decided to do it everywhere, as the mandate said. Some decided to go only to high need schools. Some decided not to do it at all because they didn't really believe in it. There are ministers of health who think there's no reason to do it, and they decided, oh, we'll just do a little health promotion. So it actually did not become universal. And then came COVID. And of course, it stopped completely because schools shut, and maybe a third of public health units have started doing it again after COVID. So, yeah, is this happening in Ontario? Not really. And if you find a child who has an eye problem, they need to go see an optometrist. Parents worry about cost. And in Ontario, optometry exams are free for children, free until age 19. In New Brunswick and Newfoundland, there's no coverage for children going to get their eyes checked, and that's true in 2 territories. Well, Nunavut's even worse because there is no optometrist in all of Nunavut to go to. But even in Ontario, where it's free, there are not optometrists everywhere. This is a little study we did in Hamilton of the number of optometrists by density of population. So if you're in Ancaster or Stony Creek, there's about 1 optometrist for about 5,000 people. But if you're in central Hamilton, it's about 11,000, 1 optometrist for 11,000 people. So it's harder to find one if you live in central Hamilton. And what is the median income in these 3 regions? The number of optometrists correlates perfectly. There are more optometrists where people are richer. We also, in Ontario, all over Canada, have far fewer optometrists in rural areas, and in the north, generally, there are very few optometrists. And then if the optometrist finds this child has myopia and needs a pair of glasses, that's the next hurdle because the parents are worried about the cost of the glasses. There are programs like I See, I Learn in Ontario. They're run by the Optometry Association, where the glasses are provided at no cost. And these are data from just before COVID. This is a free program for 4-year-olds. Only 20% of parents, and they have wide advertising. They have a good marketing department that advertises it. Only 20% of parents took advantage of that program. So you need, we're doing a terrible job in Canada, is the bottom line. And that's reflected in the study that a PhD student did with me, Afua Assar. So she used OHIP data to follow everyone born in Ontario in 2010. It's over 100,000 kids. She followed them over 7 years. And she looked to see if they'd ever had a single eye exam, because the optometrist will bill it in order to be paid. And so if we look, of course, this is age from 1 to 7 years. Cumulatively, the percentage of children who've had at least 1 eye exam. So when we get to age 7, about 2/3 of the kids have had an eye exam. 1/3 have never been to an optometrist. They're 7 years old, they're in school, nobody has ever checked their eyes. And the 5 lines are by poverty level. So the line at the top is for those with the richest parent, or they living in the richest regions. The line at the bottom is for those living in the poorest regions. So if you are living in a poor area, the odds that anybody has checked your eyes by the time you're 7 is just over 50%. So that's why there, no, that I just want to hope I've convinced you that we have an invisible pandemic. You can't see myopia. The parents don't know the child has it. It's increasing. It's a disease, and we should worry about it. That's it.